Hello guys, welcome back to my channel. Today is session 12 of machine learning for teams, and also today is the last session for machine learning. Okay guys, I hope you all understand all the concepts of machine learning. I try to cover all of them. Today I'm gonna talk about uh, spam detection email, and so that's the name of a data set. So in that we have some really interesting stuff. Then I'm gonna review evaluation metrics. Then I'm gonna complete the outlier detection techniques. Today I'm gonna talk about IQR. Okay, let's get it started. So first of all, I want to talk about a spam detection dataset. So it's like this. We have a data set like this. We have one row as target column, so it only contains ham or spam, and we have another column that's like a message or something that we receive. Based on the message that we got, we can talk about its ham or spam. Okay, so so we didn't have anything like this until now. So we usually have only categorical data like a single word, like blue, green, or ordinal data, but we never had something like this. So I want to show you, definitely the computer cannot understand the words, okay, or sentences. So we need to change it to the number somehow. And this is why we're gonna use actually count vectorizer technique. Okay, count vectorizer actually first creates a bag of words. Bag of words is like actually a bag contains all the words that we have in this column. For example, free int, in, number two, and whatever we have here. Okay, or something like this. And whatever we have in this column will be part of a bag of words. Okay, so then then that's gonna consider each unique word as a new feature. Okay, for example, as I told you, if we have something like go here, go until, and available only, each word we consider it as a new feature or new column. Okay, and then so each message represented by how many times each word appears. So it means, for example, if we have actually the word go once, it's repeated once here. Okay, the number for this feature is 1, for go is 1, for until is 1, and for example for this one it doesn't have a go or until, so for this one it's 0 for both of them. Okay, and similar things for all the words that we have here, all the words. For example, you don't say so early, for you see already, then say. Okay, so we if you see here, we have say twice. Okay, it means for word or feature say, we count it as 2. Okay, it's the number of the words that actually repeated. Okay, and for example here for then we don't have it, we just have it once. Okay, the number is 1. All right, let's go to coding. You will understand more. Okay, so here I use spam.csv dataset. So, and also I'm gonna share with you guys as well. And if you see this one, we have these 3 columns that we don't need. So I'm gonna actually not dropping, but something like that. I'm gonna consider only v1 and v2. So the data set is like this. As I told you, this one is the target and this one is the message. Okay, and here I just rename it to label and message, and the reason is I just want to understand it more. Actually, v1 and v2 doesn't make any sense to me. And here, and as you know, computers cannot understand ham or span. We need to change to number. We can use actually label encoder, as I show you in previous sessions, and or we can use something like that I use mapping. I said when we have ham we put 0, and when we have span we put 1. Okay, and then okay, so this one, and we need to get rid of this column. We don't need that anymore. Great. All right, we need to work on this column message, and we're gonna use count vectorizer as I told you. So we just initializing, and we're gonna consider df dot message or message column. And for this one, so I just want to show you actually what will happen if we see the bag of words. Okay, this is a kind of bag of words, and you see we have an array something like 8672. So I'm gonna just change it to data frame, and the reason is I want you guys to see the bag of words. Okay, great. So here we have 0, 0, 0, 0, and some other stuff, some numbers. And if you just go to other parts, you can see it's like this. Okay. For example, every single words that we have in that column, we can see here. For example, young, younger, and your, and other stuff. Okay. So it means it's a bag of words contains everything that we have in this column. Every words that we have in this column. And then I'm gonna actually say get the y as label or target variable, and like ever I'm gonna split the data. And one more thing here, I'm using a certified, and the reason is we don't have actually uh, equal number of 0 and 1, and this is the reason that I'm using a certified. If you need to more about that, I already talked about that in one of the sessions. I talked about a certified and ordinary actually train test, and also I covered a crossfire. So if you just watch that video, you will understand here. Okay, and then here I'm gonna use get search CV. As you know, we use get search CV when we want to find the best hyperparameters. And as you know, hyperparameters are like parameters for each model. Okay, for example, here for just let me run it first. So here I want to use naive Bayes, logistic regression, and SPM. For each of these guys, I have several different values. Okay, for this one, for example, for naive Bayes, I put alpha different numbers, and I want to just see which numbers actually works better for me. Okay. And similar thing for this stuff. We have C solver and penalty and other stuff. And for this one, C loss. Okay. And if you just need to know about hyperparameters of each model, you can actually read the documentation, or you can simply uh, uh, Google it. Yeah, that's it. Okay, let's run it. So in this part, I just want to ignore the warning, and the reason is I don't want to see them. And here is their CD. Here in this part, as I told you, so we're gonna check for naive Bayes, logistic regression, and SVM. So that's gonna take some time. I'm gonna stop the video till it's done. Okay. Okay, great. So now we need to actually check the base score and base hyperparameters for each model. If we just run it, so you can see I just got some other stuff for recall F1 and precision. If we back to presentation, so here I just a little bit review that. So, and I already covered this topic, but if you need more, if you need to learn more, you can actually watch that video as well. But just I'm gonna tell you evaluation metrics. So we have something like recall F1 score and precision and accuracy as well. But as I told you, if you need to know more, please watch that video as well. Okay, let's back to coding part again. So like ever, I'm gonna check for overfitting to make sure everything is right. So just to remind you, overfitting will happen when we got really high accuracy on actually train data and low accuracy in test data, something significant, something like 30%, 25%, something like that. So here we're not facing overfitting. The reason is we getting, for example, here one for test for terrain, and for test is 98. So it's almost perfect. And for this one, similar to that one, actually is 99 and 98, and same for knife base. So it means we are good. We don't need to be worried about overfitting. So here I'm gonna use the confusion metrics and just a little bit talk about that. Okay, that's gonna take some time again, but not too much. Okay, this one is knife base, logistic regression, and SVM. So as you know, everything that we get here, for example, our model predict label is ham, and actually 953 times we guessed it actually right. The true label is ham, and our model actually guessed it as ham. Okay, and for this one, for example, uh, uh, 13 times our model guessed it wrong. For example, it's guessed it spam, but in reality it's ham. Okay, and same thing for here and other stuff. So let's back to presentation again. All right. So today I'm gonna finish outliers detection. So just to remind you, outliers we define it part of the data that is out of the range. For example, if we have a data from 0 to 100, and we have, for example, we have really a high record, something like 180. So it's significantly different from other stuff, other records. Okay, or something low, really low, something about minus 100. So that's really low. Something is that's significantly different with other records that we have. So and today I'm gonna talk about actually IQR. So percentile. So last session we talked about percentile. Today I'm gonna tell you 25th percentile means 25% of the data is less than or equal to that number. Okay, for 50% we call it also median. So it means 50% of the data is less than or equal to that number. So for 75 it's similar same. And IQR, we just define it as this: IQR Q3 minus Q1. And then we're gonna actually find the lower band and upper band. For lower band is Q1 minus 1.5 times IQR, and for upper band is Q3 plus 1.5 times IQR. Okay, and like ever, we're gonna find the outliers, everything that is more than upper bound, and everything that is lower than actually lower bound. And we're gonna detect it and just drop them. Okay, let's go back to code. Yeah. So I'm gonna use the same data that I used last time. All right, so here is important. Actually, we're gonna calculate the percentile here. So for, as I told you, Q1, Q2, and Q3. So we're gonna actually calculate the IQR based on Q3 and Q1. So this is the number that we need. So based on this number, we're gonna define lower bound and upper bound. Great, and here, so here last time, if you remember in last session, I just used this technique, but this is not the only way that you can do it. So I'm gonna define actually a column as is outlier if outlier is happening. Okay, so here, is outlier false, false, it means it's not outlier, false, false, and most of them are false. But we're gonna actually count the number of outliers that we have in dataset. It's like 2077, and we just need to get rid of them somehow. And if you see my new data frame, we don't have anything uh, similar to that. And as I told you, if you just add this number to this number, you will get the original data. Okay, and this one. Okay, let's back to presentation. And here for assignment, we have a tricky part like this one. I want you guys, I'm gonna give you guys this data set as well. I want you use reviews.csv. It's from Amazon website. So, and do some data processing and do something similar to what I have done in this project. And I want you actually convert the what you call it, the message to the actually the review to the numbers and use the technique that I told you. So the tricky part is you cannot exactly use that font. I mean, you need to somehow change it. Okay, but I want you guys to do that because you will learn a lot. And then I'm gonna ask you to use MELP data, and in that you need to use three techniques here, like percentile, z-score, and IQR to remove outliers, similar to what I have done in this actual session. Okay, guys, thank you so much. And actually, this is the last session for machine learning, and I'm gonna start the deep learning soon. And see you guys there. Thank you so much, and have a good time. Bye.